So next up, we have a familiar face, James Bailey, who's COO at SubQuery and on Finality. Joining us all the way from New Zealand. What's it like in the future there, James?
It's raining, horrendously raining today. So don't look forward to Friday. Friday is not good this week.
Okay.
How are you doing, Kevin? It's good to see you again.
Oh, excellent. Oh, doing excellent. Yeah, doing great. Thank you. Thanks for joining us at Illuminate.
Yeah, no, it's my pleasure to be here, and I'm really excited to dig into it. So should I get started? I assume my slides are showing, and I'll kind of carry on with that. Yep. So today I'm going to talk to you very quickly, 20 minutes, about building dApps on Moonbeam. So SubQuery, we've been doing this for some time, and I want to share some experiences around a testnet we just finished. We just finished what we call SubQuery Frontier, which is one of our testnets. We did 3 seasons, and I want to share a bit of a story about what we experienced during this testnet. Now, this testnet was a resounding success. The third and final phase of SubQuery Frontier, we had over 2,000 individual active indexes participating. An indexer in our testnet is quite similar to a validator in another network. We had over 6,500 delegators and over 100 forum discussion posts. And the one thing is, we couldn't have done this without Moonbeam, or specifically Moonbase Alpha. It was one of the venues that we ran our testnet in. And I want to share a bit of the story around how we did this and how Moonbeam allowed us to deliver this fast, how it allowed us to scale this testnet to over 2,000 indexes, and how we took advantage of the low fees and the development model. So SubQuery Network is a marketplace for decentralized data and allows you to decentralize your infrastructure. Our kind of dream is to decentralize the data pipelines that are required to build a lot of these applications. And when you're building a dApp or a network on Moonbeam or any other EVM network, your architecture stack looks something like this. You might have a UI or a presentation layer. You might have some oracles feeding into that. Those will connect through an RPC interface provider to the chain. That chain, obviously your smart contracts run in a virtual machine, most likely EVM. In Moonbeam's case, you are running on Moonbeam with a parachain. There's also a relay chain beneath that, but you can kind of combine those two and other EVM networks. And you might have some external storage involved. And if we swap all these names in with common brand names in the Moonbeam ecosystem, you might build your front end on React. You might deal with IPFS. You might connect to Moonbeam through on Finality RPC endpoints. And of course, Moonbeam is running Polkadot as a relay chain. Now, there's a problem here. And the problem when you're building an application like this is around, well, actually, when you're building these applications, sorry, I'm just skipping these slides. You're building smart contracts just as you would in Solidity on any other EVM network. So regardless if it's Ethereum or Avalanche or Moonbeam, the same way that you build these smart contracts, the same Solidity contracts you can use. And you can use these familiar tools that we've all used, like Ethereum Waffle, to write and test the smart contracts, Solhint to obviously lint the contracts, type chain to build the bindings for TypeScript, and finally Hardhat to compile and test the contracts. And these contracts on the left-hand side here, this is actually our real contracts for our SubQuery network. But there's a problem with this, and this is around when you're building these fancy UIs, like this one here that we use to build our application, or where Index is used to manage their projects that are indexed, or they use to accept purchase offers from various consumers out there, or the UIs that delegators will use to select which indexes to support and delegate to, or leaderboards that you can use as a team to kind of score out the indexes in a testnet to decide who you want to give airdrops to and how much you want to give them. The problem is it's really hard to build these UIs, these intuitive, data-rich UIs. They're quite heavy and they're quite difficult to build, especially if you're working directly to the chain. And that's the problem. Querying decentralized data is hard. In order to build these increasingly complex applications, developers need better tools to process and query that data. And querying data directly from blockchains, it isn't feasible. Even Moonbeam, as fast as it isn't feasible to query all of that data to make that UI so rich and intuitive directly from the blockchain. So SubQuery is there to solve this. It's an open source project that allows developers to index, to transform, and to query Substrate and the EVM smart contract data that power the applications. And think of it like a custom API for your dApp. It's a custom API that we use to build those UIs. So when we're looking at the dApp stack here, SubQuery kind of fits in here on the left-hand side. It's the data indexing pipeline. It provides that data back up from those virtual machines or from the parachain into a more performance store that the presentation layer can then rely on. And that's kind of where it fits in the stack here. Now, let's talk about SubQuery's design. We've designed it from the start to be a leading multi-chain indexer. It's designed to be fast, faster than other solutions with advanced indexing caches and pre-computed indexes. It's designed to be flexible as a scaffold for your own custom API. A lot of people ask, what's the difference between you and these other data providers? It's completely flexible in the way that you can customize it to provide the exact data that you need for your user interface. If you want to build an application that is superior to your competitors, is unique in every way, you need flexibility in the way that your data is stored and provided. It's open source, you can adapt it as you will, and it's universal. It's engineered to work across layer ones, whether that's different smart contract languages like EVM, WASM, COSM, WASM, or Ethermint, or across different layer ones like Moonbeam, Polkadot, or Cosmos, Algorand, Avalanche, and soon many more. Now, a SubQuery project in a nutshell is very straightforward. I'm going to skip the slide because I'm just going to show you. It's easier just to show people this kind of stuff. And what I'm going to do is I'm going to show you the actual contract, or the actual SubQuery project that we use to build our UI. This is it here. Now, there's 3 main files that we edit. And this is a very complex project, so don't be put off by the amount of code in it because there's a lot of UIs. The first file is the shape of your data. It's a project manifest. And the project manifest essentially is a GraphQL definition. We call it a schema GraphQL. And that project GraphQL schema defines the various entities. In this case, we have a SubQuery project. We have a SubQuery deployment. And a project, of course, can have many deployments. So there's foreign key relationships. The deployment might be indexed by multiple different indexes. And I can see the various indexes and the metadata around them, the different metadata they have, the commission rate that they're set, the projects that they've deployed, the delegations that they've received, the rewards that they've earned, the last error that they were rewarded. All these entities work together to provide this rich data set. And the way that this data is stored underneath the surface, we use a Postgres database. And each of these GraphQL entities that you define is essentially a table in that database. So there might be an indexer table related to a deployment indexer table, which has then a foreign key to the deployment table, which is a foreign key to the project table. And there's many, many tables here. There's foreign keys, there's various indices, unique constraints. It's quite flexible. And then you can then query this data using GraphQL. The second most important file is the project manifest. And the project manifest is the what and the when. And this is a project YAML file. Now, when you're building a SubQuery project, when you're running it yourself, you'll just write subQL in it, and it will bring all this boilerplate in. So don't worry about this boilerplate. There's many different example projects out there. I'm showing you a very complex one. And then one of the ways this is so complex is the number of different trigger points you are. So the first part of this is the boilerplate. Most of this is about required versions of SubQuery. But then the network here, we're connecting to Moonbeam Alpha or Moonbase Alpha. We're referencing a dictionary to speed up the indexing of this project. And then we import a few different smart contract files. These are our own contracts that we built, and I showed you a screenshot of before. And then we have many different mapping functions. And these mapping functions essentially are the trigger points. Now, the way that indexing works is that you look for different triggers. And in this case, for EVM events, you kind of restrict yourself to different topic filters. Now, in this case, I want to index, let's say when an index updates their metadata. So I can update the recorded state of the indexer. So I filter for the various topics and a topic that is emitted from our contracts called update metadata. And every time that happens, I then run a different function for that. And you can combine many of these trigger points to index everything, essentially. Every delegation that's added, removed, all the unbonds requested, the commission rate changes, the different queries, the indexing lifecycle. There are many different trigger points in this project. As I said, this is a very complex project, but it shows you how you can combine all these different pieces together to build a really good indexer that indexes the data that you need. Now, the third file that we look at is the mapping file. And this is where it gets a bit complex. So the mapping file, each of those trigger points will run a mapping function. And these functions are defined in TypeScript. It's very straightforward. And I'm going to go into a mapping function that basically just looks at the staking lifecycle. So this retrieves, has various little functions that will, for example, handle remove delegation. Every time, you might have seen this back before, it was a delegation remove event. We receive that event from this function. And then finally, we then process that data. And it's very straightforward how you write these. In this case, we're extracting the arguments from that contract call or event. We're then obviously getting that delegation record from the database. We're then updating it. If it doesn't exist, we create one. And then we're updating it, and we're updating the total delegation for the indexer, and updating the total stake for the error, and then updating a few other data sets. And all these data sets can combine together to just update the data inside the store. Now, when you're running this locally, you can use Docker just to run this. And what will happen is you can write Docker start or Docker compose and Docker up, and it will spin up a virtual machine with an indexer, a Postgres database, and a query service. And you can then start indexing this data from this case, Moonbeam Alpha. You can process it according to all these mapping functions. And one thing I want to make note is you can do anything with these mapping functions. If you wanted to get the current price, so you can, of course, retrieve data, you can update data, you can create new data, you can delete data, you can, but you can make on-chain state queries. You can request the latest state of the chain at that block height. But then you can take it next step further. You can do external RPC recalls. So in many cases, people use this tool using SubQuery to build a data set for their NFT marketplace. And they will do an on-chain, also an off-chain call to get information about that artwork from IPFS or from a third API. You could, if you're doing a DEX, you could go off and make a request to CoinGecko to get the latest prices for assets. You can make any external API call from these mapping functions that you want. But this will process the data according to these mapping functions. It will save it to a Postgres database, and then you can query this data. And you can query it. We have our own backend, but we also provide a managed service where you can upload this project. And there's many other projects in there. And you can rely on a managed service to then provide. So I'm just trying to find, I think we've taken it down recently because we've been changing it quite a bit. And you can run that and then make GraphQL queries to get that data in the data set. And those GraphQL queries are what you can then call from your front-end app, React or Angular or mobile app or whatever you want. And you get that fresh, pre-computed, pre-cached data that's much more performant and faster and allows you to make much better front-end applications and provide your users with a much more intuitive and responsive user experience. So that's building a SubQuery project in an absolute nutshell, except this is obviously a really complex example. So as I showed you here, a SubQuery project is a set of instructions of how to index data. It's a data processing pipeline. And it has those three main parts: the GraphQL schema, the shape of your data, the project manifest, which is the configuration or the different trigger points, and then various mapping files, which are the actual TypeScript pipelines of taking this data and processing it this way. We have customers that have used SubQuery to build DEX applications. We've had customers that build NFT marketplaces, to build decentralized networks like SubQuery, to build data analytics to analyze cross-chain events. We've had customers that built blockchain explorers using SubQuery. The use cases of SubQuery and indexes like it are endless. It's basically whenever you need data in a more performant, more reliable, and more scalable way, using a tool like SubQuery can help. So we built the best fully featured indexer, so you don't have to. And by the way, we continuously work on this. We have a large team working on this. So when teams go and build their own indexer, it doesn't really make sense. We focus on building the best one for you, so you don't have to. And it supports EVM. In this case, the example I showed you was indexing EVM events from Moonbase Alpha. It supports WASM, Ethermint, CosmWasm, many different execution environments from around the blockchain industry. It's write once and run anywhere. So there's a large multi-chain support. We support Polkadot, we support Algorand, Avalanche, and Cosmos. And so essentially you can rely on that support. And within Polkadot, we support any substrate chain. So it is your gateway to Polkadot. If you want to build a project that can run on Moonbeam, and then you want to take that project and also deploy that on another Polkadot chain, or build your own chain, or use Moonbeam as a jumping off point to build your own chain, it is a perfect gateway to help you do that. It's got absolute performance. We focus entirely on fast syncing and indexing optimizations. It's got the power of GraphQL, so we support advanced filters. GraphQL subscriptions, which means that your front-end app can be updated as soon as data changes in the data set. Complex aggregations, you can ask the data set to give you the average or the sum of various entities, all the features that you might need. Faster reindexing, this is a cool feature. So in that data store, we keep track of the historical state of every entity. If you update an entity, we keep track that this entity had this state between these blocks. And what that allows you to ask the data set is, can you give me the state of this entire smart contract or this entire application at this block height? Who had what? Where was this owned? How much did this person own or whatever? You can ask those historic queries about that point in time. But it also allows us to do faster reindexing. If you add a new contract or if you change a contract to a particular block, you can rewind your project just that block and then carry on from there. One of the biggest pain points about indexes is whenever you change it, you generally have to reindex from the start. But with SubQuery, you can rewind your data from the current state to a particular point in time and then continue from there. And finally, it's lightweight and portable. Other indexing solutions require extremely expensive, costly, hard to manage archives that have the entire database or data set in them. SubQuery is designed to be atomic, lightweight, portable. It can connect to any RPC infrastructure, whether it's one from Onfinality or your own node or Infura or any of the other providers on Moonbeam and any other networks. And it can run in any different computer around the world. It's very lightweight. It's designed to be portable. And what that means is that it's designed to be decentralizable in the long term. And that's where we're going with the SubQuery network. The SubQuery network is going to be a marketplace for decentralized data that allows you to decentralize your infrastructure. What that kind of means when you break it down is it means that you can build your SubQuery project, and rather than you having to run it yourself, or you have to provide it to a centralized provider to run for you, which again breaks the tenets of this decentralization vision that we're striving to achieve. You can take your portable SubQuery project, and you can go out to the SubQuery network and you can ask anyone out there in the world, can you please index my data? Can you please provide this data back to me and to my users of my app? And can you do it in a decentralized, trustless way? And the SubQuery network is there to facilitate that. You as an architect of your project can provide that project out to the world. Any indexer around the world, whether you know them or not, can index that data, and then your consumers of your app can exchange SubQuery tokens to retrieve that data from them in a decentralized way. And we're building this right now. We've just finished the testnet. We're still working on some contracts, but it's going to be launching soon. And essentially, it's going to revolutionize the last part of that infrastructure stack that is centralized. If we go back all the way to the infrastructure stack slide I showed, most of these pieces have been decentralized. And the last one of them is the data provider. And the SubQuery network is here to solve that. Now, one of the weird things about the SubQuery network that I like to say is it's designed to run obviously thousands of different SubQuery projects in that decentralized way. But in itself is reliant on one SubQuery project to provide that UI, to provide that experience for all the participants. That SubQuery project I just showed you, that complex one built to work with Moonbase Alpha, the subquery network relies on that user interface for people to interact with it. And that subquery project will be one of the first itself to run on the subquery network. So we're doing the ultimate dog fooding ourselves at subquery. We are having to build with our own tools to help us build the product that we want the future to be. And it's a perfect example of how to build, a huge, scalable, decentralized, and open DApp and protocol. So we're very pleased and very happy to work with Moonbeam on this. Moonbeam has been a perfect place to kind of build our testnet, and you can see, we've done a lot of work and really kind of been able to build this complex subquery project with various different pieces to make it work. And we'll be launching the network very soon. We're just waiting the right time. We're just finishing off various more features to bring up to feature parity with some other decentralized infrastructure providers out there. But it's very familiar. And as you would have seen in this demo, it's very straightforward. Now, if you want to learn more, we have an academy with a ton of documentation, quick start guides around how to build Polkadot. We also have quick start guides around, obviously, the Moonbeam side of things. But one of the best things that we have is we've just done some work with Moonbeam to build or to deliver a workshop with the Moonbeam Moonbuilders workshop. And you can search that, Moonbuilders SubQuery, and you'll be able to find, I think it's in here somewhere, a Moonbeam workshop. I'll find the link and I'll share this out after the call. But thank you very much for your time, everyone, today. And thanks very much for having me on. It was a pleasure to talk to you and walk through how we ourselves went through this process of building a really scalable, large, decentralized application that supports over 2,000 indexes using our own tools, but also using Moonbeam. So thank you very much.
Thank you so much, James. This is a very enjoyable talk. And I was really glad to hear about the subquery network. And that was really, really fascinating to hear. And of course, I think at the end you mentioned you were talking about Moonbuilders Academy also. So you have the subquery Academy, but you also have Marta Adamczyk's course.
Yeah,
so
and there's a 5-part course or 5-part workshop that goes through every step of the way of how to build a subquery project on Moonbeam, broken down really easily, and she did a great job on those videos.
I think Kathy just posted it in there.
Awesome.
Thank you so much, James. Yeah.